Okay, the final question on Edx M2 January 2010, that's question 8, is on projectiles. Here's the question. Take your time to read it, pause the video, and then continue playing when you're ready. Right, now this is not a particularly nice projectiles question for one reason especially. The initial velocity is given in a rather strange form, and it's given here. It's a standard projectile in all other senses. A projectile on horizontal ground like this. I think I'll draw that again, like that, say. Initial velocity here. Projected from O, moves freely under gravity until it strikes the ground at A. There. Okay. And they mentioned the position vector. So that's a strong hint to do this question in vectors, vector form. Let's do that then. So the usual way with these questions, we start off with the acceleration is just 0 in the x direction, minus 9.8. Now the funny bit, the initial velocity, u, is in this case, read it carefully, because I copied this down wrongly at first, u in the I direction and uc in the j direction, which is different. The general velocity then, constant in the x direction, v equals u plus at in the y direction becomes uc minus 9.8t. And then position vector, the usual working really, but just with a slightly different expression for initial velocity. So uct minus 4.9t squared. Check that you're happy with those expressions for x and y. Now to get the Cartesian equation, which is this one here, y in terms of x, that's fairly standard bookwork. You write down x equals ut, and then y equals that, and you substitute for t from the x equation into the y. So t is x over u, and y becomes u c x over u minus 4.9 okay, which tidies up to what they want. Y equals cx minus 4.9 x squared over u squared. Okay, 5 marks for that. Let's press on. So we've got that first part. I've copied that part of the question down again. We know u is 7, and they tell us OA is r meters. Now OA was the range of the projectile. Oops, beg your pardon, I've not got the right pen. Not very good at drawing smooth curves with this. OA is the range, r. And if I put that underneath, that would be better. The greatest height reached is h as well, capital H. Okay, the first thing we can do is use the fact that u is 7, so let's rewrite that. We know y equals cx minus 4.9 over 49, that's x squared over 10 then. That's what the equation at the top there becomes when you put u equals 7. Now, use that result. It says for part B here, use the result or otherwise. Well, it would be sensible to use that result then. Let's find r. So to find r, what's special? Well, y is 0 at x equals r. So putting that in, we've got 0 equals cr minus r squared over 10. So r squared over 10 equals cr. Just rearrange that a little bit. R squared minus 10 CR would equal 0. R into R minus 10C equals 0. So r is 0, which is the point of projection, or r equals 10c. So that's the answer we want, r equals 10c. That's the range of this projectile. Now we've got to find the greatest height. Well, without doing anything too clever about this, it's an ordinary projectile on horizontal ground, so y equals h at x equals half r over 2, which is 5c. So let's put x is 5c in and y is h, and rearrange that. So capital H equals 5c squared minus 25c squared over 10. And that gives us capital H equals 2.5c squared. So that's another bit done. We've got a total of 6 marks for that, for finding r and finding h. Not quite finished though, there's one more bit at the end of this question. And at the end of this question it says, when p is at the point q, we don't know where q is, the velocity is at right angles to the initial velocity. Now, what we've got is we've got an equation for the curve as y equals cx minus x squared over 10. We've also got the initial velocity was uc. In other words, the components look like this. U along, uc up. That was the initial velocity. Okay. So the initial gradient of the curve was uc over u, which is c. And the best way of doing this, rather than getting involved in finding the velocity in time t, bringing t into it, the best way of doing this, since you've got the curve, is to use pure maths, core maths ideas. The initial gradient was c, and we want to find the value of x. So we don't want to bring t into it. We want to find the value of x when the gradient is perpendicular. So we want the gradient required, I'll say, a gradient perpendicular to a gradient of c. Well, you know from pure maths that that's minus 1 over c. Because m1, m2 is minus 1. So how do we get the gradient? Well, we differentiate. Now, dy by dx is c minus 2x over 10, x over 5. Well, we're nearly there now. We've got an expression for the gradient at any point on the curve. We know it needs to be minus 1 over c. So let's rearrange that. So x over 5 equals c plus 1 over c. Therefore x equals 5 lots of c plus 1 over c. Yeah, that's right. That's the right answer. 6 marks for that. So those 6 marks were easy so long as you thought of using the gradient, but not so nice if you didn't. You could still do it by bringing t in and thinking about what the velocity would have to be vertically, but it's far easier this way. Going back to the first part then and just looking at the marks. No, that was the first part there. Yep, that's it. So there was basically a mark for seeing the position vector and 3 marks in total for setting this up. Okay, there was 3 marks for setting up the position vector and going through the usual steps of setting up the equations for projectile motion. It's 3 out of 5. Then for putting the t in, substituting in and getting the equation they want, there was another couple of marks, 1 method, 1 accuracy. Right, that says A. Carrying on with that, there was, for these bits here, there was a total of 6 marks, and for putting, just see where the 6 marks comes from. Right, there were 3 marks each. There was an M1 for putting y equals 0, and then an M1 A1 for correctly working out and finding R equals 10C, and likewise there was an M1 and an M1 A1 for finding the H. And then for the last bit with the gradient, yeah, there was a lot of marks for this, really, 6 marks. There was a B1 for finding the original gradient, an M1 A1 for differentiating, there was 6 marks in total, another M1 A1 for putting it equal to -1 over C, and an A1 for the answer. Yes, that's it. That's the 6 marks. Okay, that was January 2010, question number 8. Thank you for listening.